Another class, another math class. Today we'll be talking about indices. Indices. What do we mean by indices? We are talking about exponents. Exponents. Must have heard of exponents, exponential, when a particular number is raised to a power of another number. That's what we call indices. X is raised to the power of a, 2 is raised to the power of 4. Y is raised to the power of j. Exponents. Then it means this x becomes our integer, while this becomes the exponent. The power to which something is raised. 2 raised to the power of 4. 4 here is the exponent or the indices. There are laws guiding indices. We have the addition law, we have the division law. Today we want to look at the first law. Now all these laws will take foot and they will take hold where x, a, b, whether it's the exponent or in the integer, is not equal to 0. What do I mean? Is not equal to 0. What do I mean? If I say 2 over 4, it means that this 2 is not equal to 0, and this 4 is not equal to 0. Say x raised to the power of 4. It means that if this law of indices we're going to talk about is going to hold, x is not equal to 0, and 4, which is the exponent, is not also equal to 0. So the first law is the multiplication law. If we have x raised to the power of a, and then we have times x raised to the power of b, what this will give us is x. If they have the same base, the same integer, the same base, it will be a plus b. This is the base, this is the exponent. If they are the same base, 2 raised to the power of a, then 2 raised to the power of b. These two here are the same base. We pick one of the base, 2, and then we add the exponents together. Let's give an example. Number 1, 10 raised to the power of 4 times 10 raised to the power of 5. They have the same base, the same integer. We'll pick one of the base, 10, and then we add the exponents. If the relationship is a multiplication sign, 4 plus 5, what does that give us? 10 raised to the power of 9. How do we check if this is right? 10 raised to the power of 4 is equal to 10 in 4 places. And then 10 raised to the power of 5 is 10 in 5 places. How do we do this together? For us to have 10 raised to the power of 4 times 10 raised to the power of 5, it will be 10 times 10 times 10 times 10 times 10, which is the 4, times 10 times 10 times 10 times 10 times 10. How many 10 do we have? 1, 2, 3, 4. Sorry, it's 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. What we eventually have, we 10 to the power of 9. The first law, once we are multiplying and we have the same base, what you need to do is just to add the exponents. They have the same base, just add the exponents together. Just add the exponents together. Let's look at another example for the multiplication of indices. Another example, this should be number 2. Let's look at, we're looking at, let's say we have 3 to the power of y times 3 to the power of x. What we only have is 3, pick a base, then y plus x. That's all. 2 to the power of 4 times 2 to the power of 5. What does that give us? Take a base, 2, 4 plus 5, that's 2 to the power of 9. We could check this. We could check this. How do we do that? 2 times 2 times 2 times 2. That's to the power of 4 times 2 times 2 times 2 times 2 times 2. How many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. 2 to the power of 9. And what does that give us? 2 times 2, 4, 4 times 2, 8, 8 times 2, 16. That will be 16. 2 times 2, 4. We can say 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 6 times 2, 32, 32 times 2, 64. 64 times 2, that will be 128. 64 times 2, that's 128. You can say 64 times 4, that's 6. 124, 256. That will be 256. That's the answer we'll be having. 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 16 times 2, 32, 32 times 2, 64. Okay, sorry, there's a mix up there. 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 16 times 2, 32, 32 times 2, 64, 4 times 2, 128. 128 times 4 now. 32, that's 2, 3, 8, 9, 10, 11, 1, remainder 1. That's 5, 12. 5, 12. This will be the answer. So rule number 1, if we have the same base, the exponents, and we have to multiply the indices, the exponents only add up. The exponents will only add up. Let's take another example. A raised to the power 3 times a raised to the power 9. A. Same base. We pick one of the base, then we have the exponents, the indices. That's a is a to the power of 12. If you want to be sure, we want to check. That's a times 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 a. 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you count all the a's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. A to the power of 12. Same as what we have done. Let's give another example that has to do with maybe a mixture of figure and alphabet. We have 5y over 2 times 4y over 6. This is an extrapolation of the formula above. What do? We have a base, which is y. Then we have figure. What do we do in this kind of case? We bring out the figures, the numbers, 5 times 4. Then we pick out one of the base, and then we add the exponents. 5 times 4 is 20. We pick out the base. 2 plus 6 is 8. Let's do another one. We have something like 3x squared times 6x raised to the power 5. We bring out the numbers. 3 times 6. Then we bring out our base, common base. We add the exponents together. That will give us 18x over 7. So with these few examples, I'm sure that we have given enough example to buttress this formula. When we have common bases with their exponent multiplying themselves, what we do is we pick a base, we add the exponent. We pick a base, then we add the exponent. Let's look at the division. We have, that's rule number 2. Rule 2. We have xa divided x raised to the power b. What we'll do is, whenever we see division, we just use a subtraction sign. This is rule number 2. Same base, and we are to divide. What we do, we subtract the exponents from themselves. Let's look at an example here. In our next class, we'll be considering rule number 2, in which we have the same base, but we are to divide, not multiply this time. Thank you very much. We want you to please like, subscribe, and share. Thank you very much.